So in this video we have examples. So example 1, in the CS plane I have this terminal side. The initial side is on the positive C axis because it's in standard position. That angle, I'm just defining it as going clockwise one time, and then 2 times, and then this additional amount here, which looks like 3 pi over 4. It's going clockwise, so it's a negative angle. My reference angle would be there. It's the angle that's the shortest measurement to the c-axis, and you make it positive, as if it were the interior angle of a triangle, right? So reference angle there is rho. Looks like pi over 4. So what is x? X is we're going clockwise twice around. That's minus 4 pi. And then we go an additional 3 pi over 4. So I'm just counting 1 pi over 4, 2 pi over 4, 3 pi over 4. Now, you don't have to memorize that. You can count, right? And that's in the it's clockwise, so it's negative. Right, and this is the first 2 times around clockwise. 2 pi each, or negative 2 pi each, I should say. And then I just put them over a common denominator and combine the numerators. I get negative 19 pi over 4. So that's that angle. The reference angle is easier. It's just pi over 4. Now, the text mentions this, the sine, that in the case that you're in the third quadrant, sine x is the opposite of sine of rho. I don't really think that's particularly helpful. What I do is I just draw this 45, 45, 90 degree right triangle, right? Because it was pi over 4, which is 45 degrees. And what I do is I just label, well, the length of this side here is 1. This is the template size, 1 square root of 2. But it's in the negative direction, so I just label it negative 1. I'm actually labeling it with the coordinates of this point here. That point there is going to be negative 1 comma negative 1. And so I just label these sides with the negative 1 and the negative 1. So in other words, they're not really distances there. They're signed, kind of like signed distances. And then the hypotenuse is always positive, and that's going to be square root of 2. And now that I have this triangle, I can write out any trig function of that angle that I want, just using the opposite over adjacent, opposite over hypotenuse, etc. So the only difference between this and what we did in the previous section is I have the negatives there, telling me that from the origin, I'm going left 1 and down 1 to get to this point here. From the origin, left 1 and down 1, so negative and negative. Okay, so that's the trick I like to use, rather than memorizing which quadrant you get sine of rho and which quadrant you get negative sine of rho and all that junk. To me, this just seems a lot easier. So the sine of this angle, negative 19 pi over 4, sine is the opposite angle, the opposite side from the angle over hypotenuse. It's negative 1 over square root of 2. It's that simple. See, so now we're really using triangles again. But they're just, the legs are kind of signed differences. They plus or negative, plus or minus, or positive or negative if you want. Okay, here's a second example. X is negative 5 pi over 3. So first you have to figure out where that is. And so I just broke it down into, well, it's negative pi, which would be, let's see, negative pi would be 3 pi over 3. That leaves negative 2 pi over 3. So it's negative pi minus negative 2 pi over 3. So I go around, I go around from here, negative pi, and then negative 2 pi over 3. Well, there's 1 pi over 3, 2 pi over 3, right? That would be 3 pi over 3, okay. So I end up over here, which is the same thing. The reference angle here would be, right, it would be pi over 3. But that's my actual angle that they gave me. Right, reference angle pi over 3. So, yeah, okay, sine x equals sine rho in this case, because it's in the first quadrant, that's why. But we're not doing it that way anyway. So, sine of negative 5 pi over 3 equals sine of pi over 3, and therefore, but see, you can also see it this way. See, these legs are both positive, because it's this point. These are really the coordinates of this point, and this point is in the first quadrant, so they're both positive, right? And this is my template because it's this is 60 degrees, or pi over 3, and so it's 1, 2, square root of 3, and then from there I can get any function I want. Sine of that is opposite. Sine of negative 5 pi over 3 is opposite over hypotenuse, square root of 3 over 2.